Yeah, welcome to a tech talk from my side. My name is Felix Frischmann from FFR Engineering, and I'm going to talk about simulation and early product design. So modeling and some issues of a new software Ansys Discovery Live. So the thing is, first about us, I do personally a lot in the field of CAD, CAM and CIE, so technical strategical consulting in this area, numerical simulation, pre-processing, complexity analysis, and investment and startup consultation. And we have a lot of partners, Locus, my new company, where we do some software development, but also external partners in the area of CAD, CAM and CIE. Yeah, so in this area we are have a quite big expertise and are running some projects. And in this field, I do, for example, develop modules for other companies, or I do freelancing. And here you see some of my own projects, which are the generation of rotor blades or propellers, some pre-processing software, as well as something in the building sector or in the CNC sector. So you see all of this has something to do with geometry, pre-processing, and a bit of simulation. And this is why I decided here to make this tech talk to talk about the product design and simulation. So the goals must be that you want to have simulation support in your early product development phases. And these early phases, you usually have a knowledge-based product design, and you don't have so much simulation support yet. This should change in the future, and if this should change, you need easy and fast simulation with only moderate precision. And it's more important that this thing is highly interactive and you give dynamic feedback. So what do I mean? Here I have some example of a construction I did myself. And typically the engineer might start really from scratch, either digitally or on a whiteboard, drawing something, giving some ideas of dimensions, of construction principles he either knows or he might want to explore. And these ideas he brings in discussion with his colleagues to a CAD model. In the early phases, the CAD model must not be highly detailed. It's more about building the mechanics and try to get an idea of how this whole system should look like. And it would be nice simply to get in this stage really also simulation support to, for example, investigate if those junctions work, how those connections should be done, what are the stress maximums, and just to get an idea as a feedback. And this process of sketching, modeling, and then a simulation, it's important to have something easy and fast. There are some new methods like this fictitious domain methods that will allow you not to mesh and go around this complicated pre-processing issues. But then the other way, you want to have easy ways to visualize results and bring that back to your cycle to discuss again the ideas and simply explore your design space with your colleagues. This is what a nice solution would look like to integrate simulation in an very creative process of engineers in the early phases, trying to explore how a solution or construction could look like, where are the critical points, which points might have to be improved. So let's have a look on that. So here we have this model in a software called Rhinoceros. I just simply like to work with this software as a classical CAD. It's not really so much about product development. The model consists of several distinct phases or solids in the software, and you might have here some details already, which of course mechanical here in this 2.5D model don't make so much sense. What I like about the software I will show now, it's quite nice for making some freeform modeling, for example here blending in the surfaces from the two sides. That's simply nice and I can play around. It's very popular with designers in the early phases, for example also car designers or in the architectural world for some freeform modeling, or also in different kind of, for example, ship design or propeller design. Now because it's an easy CAD software, very intuitive really for the process of somehow freeform modeling. So let's take this model and now export it into a step format, because step is very widely known. Here I have already prepared, so I will just override that one. And doing that, we have the model given in a step format. And now it would be nice simply to also simulate something on that. So we start Ansys Discovery. This is this new pre-tool, or this new tool from Ansys. It's a technical preview, so a beta phase, and we load our step format. This whole system is built upon SpaceClaim, Ansys SpaceClaim, so you could also model in here, but I simply decided to model in my own modeling software. Nevertheless, here I have my model now giving in this SpaceClaim simulation add-on, I would call it. I select some faces and make solids out of them. Now, because now they are only like faces, I need a solid structure. And here I simply add now some values for extruding the surfaces to form a solid object. So you see here in the end we end up with one solid, and then there's a nice feature of having simulations within your SpaceClaim as an add-on. There are thermal, stresses, modal, and so on, and we will select modal analysis. This is always a nice tool to investigate the mechanical behavior of a structure, and we run this modal analysis, and here you see how this solid body has his modal behavior, and we can play around a bit with the scaling and so on and the speed of animation. You see there are some gaps, but they are like a visualization point of view. And the nice thing is you can interactively go there and, for example, assign new boundary conditions, like here fixed support on both sides of the lower part, and while you do that, the simulation will interactively change. So it takes a second, but then when you have done it, it interactively changes the behavior, and now those things are fixed, so they're much stiffer down there. So you see the different modes here, either on the upper bar or the things behind, this construction behind there, because laser core are not so stiff anymore. And like this, you can investigate a bit your structure. I personally like really a lot to do modal analysis before doing any other kind of observations, to get an idea about the stiffness of the structure and so on and so forth. So you could, for example, discuss about stiffness. You can also make here stress analysis, so you can put some boundary conditions like forces on some parts here, and I will also put it at the front. So if somebody would pulling this part of the structure, and while doing that, you see here I have to select the correct button, and while doing that I simply, in this case in the X direction, simulate a pulling on this part of the structure, and while running then here really interactively this numerical simulation, I get an idea again on how the structure behaves and where are, for example, the stress concentration points. So I increase a bit here the value so that you can actually see something. You have to press enter, and also you can hit, I will do it now, hit here again the simulation button, so you see how your structure deforms under this boundary condition, this load boundary conditions. And the same like before, you can interactively select faces and assign new boundary conditions. Now we will do that here now, and again say this might be fixed, and on the other side as well. And then of course we know that basically only the upper part after a while, when the iteration is done, will deform. And on the back side, I think we haven't done it properly before, we will place again a force boundary condition facing downwards. You see immediately the error where the forces are supposed to direct, and here you see how these things behave with these two load boundary conditions assigned. So I think this is a very nice way interactively to discuss also with the designers who have a knowledge-based approach but maybe are not or don't have yet the tools to really make numerical simulations upon their intuitive way of designing, to discuss, for example, if you need some more stiffness somewhere, if you have to adjust the thickness of the structure and so on. And here you can also make a thermal simulation. Now, of course, in this structure doesn't really make sense, but I will just show it anyway. Place a temperature boundary condition, and you see here how the temperature distribution is. I think this whole process makes only sense if you want to bring it really to the design process, if you can also script it, or if you can prepare a workflow and interactively, or this interaction we've seen before, to bring it somehow into something digitalized. I simply like it, not only to play around and see values. In Ansys, theoretically, you can always make those scripts and basically build up a Python script. That Python is very nice. In the other software, basically too, which you have seen before, the CID software, also has a Python interface. And we will load again the sledge model, I call it, and you see then in the script environment how the loading is also recorded, so you can live record that. And I will repeat the steps then before, for example, the extrusion of the faces, and from there you will see that also this is being recorded. So if you can automate that, or if you can provide in a simulation environment such a script so that you can really play around with parameters, then I think this is a nice way to really explore the design space before you might later go to detailed simulation and to go to, I would say, for example, also optimization tools to really find the optimum. But typically first you have to limit design space, especially in huge multi-objective optimization problems which you typically have in engineering, and give the engineer intuitive approach to limit the design space by his ideas, knowing what target values he might tackle. I think that's typically a very nice feature, so you can here play around. You can run that script now after you have recorded it. So what will happen is that the whole model will be reloaded, and you can also play around a bit with, for example, the thickness of the extrusion of the upper part. I think here actually it's a technical preview, so I was talking to one of the developers. I think this whole scripting is not yet properly integrated. Now we can still play around here. We can change, for example, here from 9 to 12 millimeters extrusion thickness. If we run again the script, you see how the thickness changes, but I'm not actually sure if this really influences yet the simulation results. This is something for sure which will come. This is something essential for this kind of investigation, but I simply think this might not be totally integrated. But I showed it anyway to give you the idea that this might be of real value. Okay, this was it from my side. Thank you very much for listening. If you have any more questions, don't hesitate to contact me or my team, and we will be happy to help you to find proper tools for your design process. Thank you very much.